Park Ranger Jake Holgerson walks beside some petrified trees.
Visitors are sometimes surprised when they see this famous forest. We're used to forests being vertical, for one thing. This one is mostly lying down. And some of the logs look like they've been cut. To figure out what's going on here, you have to first picture the world of what is now petrified forest 220 million years ago.
A painting shows early dinosaurs and other reptiles and spindly-looking trees.
Some of the trees then looked more like giant feathers. There were also some conifers, cone-bearing trees similar to our spruce, pines, and cedars. But they looked a bit different.
Another part of the painting shows old and dead trees along the bank of a river.
Then, as now, trees were part of the natural cycle. Most of them, when they died, rotted where they fell and returned nutrients to the soil. There was also another important source of soil nutrients.
Molten lava bubbles up from a volcano.
Active volcanoes surrounded the area and inundated the place with lava and volcanic ash.
A column of smoke rises above a volcano.
Volcanic ash is often rich in silica. Nature was setting the stage for a 1,000,000-to-1 combination of ingredients.
A standing dead tree wobbles in the wind.
Some trees, instead of falling on the ground, fell into rivers.
Sometimes above, sometimes below the water, we follow the tree until it grounds on a riverbank.
Down the river they drifted, and a few became stuck on beaches or sandbars. Floods started to cover the tree with sediments, and smaller branches became waterlogged and broke off. This process repeated several times, until the tree was whittled down to its trunk. Eventually, mud, sand, and volcanic ash covered the tree completely. More sediments piled into layers, hundreds of feet thick, that over thousands to millions of years compressed into rock.
A cross-section of the rock shows our tree again.
But inside the rock, a few trees were not crushed and destroyed. They turned into stone themselves, thanks to those volcanoes.
A volcanic ash cloud with swirling flakes flying around in it.
The silica from the ash, under just the right conditions of temperature and alkalinity, dissolves in water.
Brown liquid seeps along tubes between wood cells.
The water flowed through the ground and into the cell walls and hollow spaces of the buried wood.
Transparent crystals form out of a bluish liquid.
Then the silica crystallized into quartz, replacing the wood cell by cell. The process is not completely understood, but it is thought that logs might have been highly acidic, forcing the silica to crystallize. In the end, tiny crystals less than 1/200th of a millimeter were formed. Slowly, the rock-hard crystals formed exact replicas of the logs they replaced.
The wood cells fill up with bluish liquid.
Pure silica, though, is almost colorless. Traces of other minerals like iron and manganese oxide gave us the colors we see today in the petrified wood.
The color changes to reds and yellows.
That process, multiplied by several thousand, produced a petrified forest.
An underwater view of a log jam. Looking down on ridges of sedimentary rock.
For millions of years, it was locked up in the middle of hundreds of layers of sedimentary rock, as rivers and oceans came and went. As the rock layers bent and moved, some of the stone trees cracked and broke, leaving those sharp edges that looked like they were cut with a saw. Finally, these rock layers eroded away and brought the long-buried trees to light. A 1,000,000-to-1 long shot that is the centerpiece of Petrified Forest National Park.